Hello, my name is Peter Raymer, and today we're going to talk about how to use D365 try-catch statements. Now, maybe you've seen these before and wondered what they are, where you have a try statement like this with a curly braces and then a catch statement. It kind of looks like an if-else statement. Well, these statements are for exception handling. Exception handling is used when something unexpected happens in the code, maybe an error message happens, and you want to be able to continue or provide more information to the user as to when and where that happened. Those are really the two main scenarios. But try-catch statements can be a little bit more complex than you might imagine, so let's jump in and take a look. First, before going into try-catch statements, let's look at basic messages and how they work. So I actually wrote this basic message method. I'm going to click start and let's debug the code so we can walk through several examples. As that's loading, we can look at the code. There's basically three common messages that you can show to the screen. One is an info message. You use this global function called info. You pass in the message that you would like to display to the end user, and that message is going to be shown in a blue background, and I'll show you that in a second. This is really just informational. You're not warning the user that something wrong has happened or an error. This is just good information for them to know. And then a warning statement uses this warning global function. Again, similar information where you can put text into the method, and then that will show the message with a yellow background. By best practice, both a info message and a warning message won't stop your thread. Whatever operation that you're currently doing, inserting a record, saving a record, running a batch job, you're kind of indicating to the user that the process is continuing. A warning might need to tell the user there's something they should investigate, but the process has gone through. You've not done that operation. Whereas a error, by nature, when you use this error function, it's going to use a red background. And by convention or best practice, when you have an error, you typically need to use this throw statement, or you need to stop the process. You're indicating to the user, we're not going to save this record, we're not going to process it, whatever your operation might be, because something is gone wrong or the data is not appropriate for you to do that. So here we're just pretending we've got an info, we've got a warning, and we've got an error. In this case, when we use the throw statement, the system is actually going to stop running the code. So sometimes you'll see that you'll return out of a method, and that's an okay way of handling error. Other times you say throw, which is a programming way of stopping the entire process, and then the base system will catch this. Notice we will not run this last line 31. So if I do that, it jumps to the end of my method and all the way out. If I let it run and I look at what messages are shown, I can see the three that I would expect. My info message in blue, my two warning messages in yellow background, and then my error message with the red background. So that's all really fine and good. But how does that have to do with try catches? And the answer is that typically, and in most cases, you can just use basic messages like this. You can have an if condition that says if the data is not set up right, show an error message or warning or info, whatever that may be. And those are perfectly great for when you know what the issues are. Try catch really comes into play when you are not sure exactly when an error message might happen, or you can't anticipate all the scenarios. So a common example might be a divide by zero error. Again, in many of those cases, you could write an if statement and say, hey, if we're trying to divide by 0, then prevent or show an error message before that actually happens. But then there's other cases where there may be a deadlock or an update conflict, or an error message in an outside DLL, lots of other cases where we just can't anticipate every single error message. And so a try catch statement basically says any error that actually happens, anything that's thrown inside these two curly braces of the try, we're going to continue running code inside this catch statement. And then really there's kind of 2 or 3 benefits of this try catch statement. One is by running further code in the catch statement, we can provide further information as to what went wrong. And you'll see that in a few further examples where we display out the item ID of exactly what went wrong. Second of all, we can continue on with a process. Again, I'll show you another example in just a minute where we're looping through records, and when one errors, it doesn't mean we have to stop processing all records. We can continue on with the next record, whereas if we did not have this try catch statement, the system would throw the error all the way out to the calling system and stop the process entirely. And then thirdly, whenever we do have a try catch statement, we are going to roll back any TTS begin and commit statements that we have inside this try catch. And so we're going to undo maybe some of the changes, the updates that we made or inserts, which is good because that gets us back to a steady state. So again, kind of the best way to explain the different ways we can use try catch is to run through some examples. So actually I'm going to hit stop on this. Let me switch to this runnable class that I've set up. I'm going to say set as startup object. I'll click start and then we'll let this next example run. Okay, here we are running through basically 6 different examples that really explain how to use try catch. The first one's the most basic. Let's step into this method. We're going to get this error message, or info message that you may see. This is a good opportunity for me to explain this. It's saying I'm trying to step into the code. Are you okay with that? And I can say yes and step into this method. All right, then from here I'm going to push F10 to step through each line of my code. And so I've got an info statement that's going to show in blue, and then I'm going to simulate like a divide by 0 or some unexpected error. Again, it's important to know normally this is going to be a throw error. If you had a throw error, that'd be silly because you would never write any code after that throw unless that was inside some conditional block. But in this case, I'm simulating an unexpected error happening. And so in that case, instead of running this info statement at the end, we're going to go into this catch statement. And this gives us the opportunity to write more helpful information than what would otherwise be displayed to the user. And so I would say typically as a developer, you may not initially write a try catch statement, but after you've got a process that occasionally has certain error messages, you may choose to add a try catch to give more error messages around, or more messages around what happened when that try catch happened. So here we go, we get another info that says additional code can be run in that catch statement. All right, that's the very basic one. Now let's look at a more complicated one. Let's look at a try catch with a loop. And so again, this is really helpful to use in batch jobs, in sys operation framework batch jobs, where one particular record may have an error, but instead of rolling back the entire process, you may want to just roll back that one particular transaction or one particular record and continue on with the rest of the records. So here we go. I'm going to loop through all of the invent table records, which is the item records. I'm going to put a try catch block around all the inside of this loop. And I'm going to first give an info message saying, hey, which item are we processing right now? We're processing 0001. That's great. We'll let the user know. Now let's pretend that some validation error occurred that we didn't anticipate. Again, normally I wouldn't write code quite like this with a throw, but we're simulating that some unexpected error happened. Here, the error message can be thrown. I can then have a catch statement where I display more information. And this is where it's really helpful because I can use the string format global function and say an error occurred while processing item %1, and I can actually display out exactly which item had an issue. Any try catch statements that I had within this try statement, any TTS begin and commit statements are going to get rolled back. So any updates or inserts that I tried to do on this item are going to get rolled back, but that's okay. We want that. It gets us back to a steady state. But now, because I caught the error, it's not going to keep throwing and stop all of the code in this method. It's going to allow me to keep running code after the catch, and that's what's really powerful. I can come back in here. I can come back to the while select. It's going to select the next item, 0002, in our list, and same thing, we can simulate that the error message happened again, and it can show which item happened. And then I've got a little counter, so I'm going to set this to be false after 4 times. I'm just going to hit F5 to kind of simulate that happening. So we had the first 4 of these records error. Now let's pretend they succeed. So when they succeed, we can have it go into this info statement, bypass this validation error. Now finally we get our info statement saying no validation errors have occurred, so we're good to go. We can add additional code to process that record. Phew, that's great. Now just for fun, I can break out of this after kind of 6 times here. All right, let's walk into our third example. There are actually different types of catch statements. So you'll notice here I have a catch statement for error, catch statement for CLR error, catch statement for deadlock. These kind of work like if statements in the sense that they're saying go into this particular catch statement if the exception that is occurring is of a particular type. In this case, it'll be CLR error message. So we can actually take different action, show different error messages depending on the type of exception. If we don't have the parentheses, we're basically saying catch any type of exception. And you can go into the documentation that I've linked to show you all the different types of exceptions. Typically, I just see these few: error, CLR, error, deadlock, and upgrade. Let's see, update conflict. That's the other one. But let's see how that works. So if I walk through this code, in this case, I'm going to call this .NET method that is designed to fail. It's going to cause a CLR exception. So when I do that, it's going to bypass this catch statement with the error and go straight into the catch exception CLR error. So very cool, because now we can explicitly say, hey, this was a CLR error as opposed to a different type of error. We can use this function get last exception to get out the actual string. Exception has been thrown by the target of an invocation, and display that to the user. And hopefully that's helpful to the user to understand what's going on. If not, we can kind of display our own message. All right, so that's our different types of try catches. Now, how do we use the retry function? And what is that? Let's step in and I'll show you that example. Retries really occur when we're trying to update records in the system, and maybe there's a bunch of different processes that are trying to update that same record at the same time. If that happens, SQL Server can throw a deadlock error or an update conflict, basically saying, hey, this record's busy and we waited for a little while to try to update it, but we don't want to wait forever. We don't want to lock up your system, so we're going to throw an error after a certain amount of time of waiting. Well, we can actually retry if we know that this is common and we need to give it a little bit more time. So here you can see we've got a try catch. I'm going to pretend that a deadlock error has occurred. It hasn't, but again, normally you wouldn't write this if statement, but this is the easiest way that I can simulate a deadlock error. In this case, it's a regular error, not a deadlock one, but we're going to pretend it's a deadlock. So then it goes into our catch statement. I can then do some cool things like this where I have a counter and say, hey, our deadlock counter is at 0 times. This is the first time we're coming into the catch statement. Let's increment that counter by 1. Then let's use the sleep function. This is very optional, but you could say, you know what? You waited for a little longer. We think if you wait a little, if the system waits a little bit longer and tries again, this might go through. So let's go ahead and wait 1,000 milliseconds or 1 second. And then let's use this retry keyword. And what that does is it's very cool. It will actually go back to the start of the try statement. So if I hit F10, I can see it goes back right here, and then it's going to try again. In this case, it's going to fail. I'm going to increase our deadlock counter. It's going to wait another second, and then we'll do this essentially 5 times. Once we get to 5 times, then we can say, okay, you know what? We tried 5 times. It's still not working. Yes, let's not hold up the user system even longer. So let's let it actually fail. So I'm going to add a breakpoint here. I'll hit F5 on this, and then it'll come into here once our deadlock counter has hit 5 times and say, you know what, there's still a deadlock after 5 times. Let's have you try again later. Maybe that record will not be in use later. Okay, that's our retry example. Now we've got 2 more cool examples to show you. One is a nested try catch. I know I was asked to write an article and show a video about nested try catches. So the next 2 examples are based on that. So let's take a look. So nested try catches, meaning like tries each with a catch inside of it like this, these do actually work within X++. So if we throw an error message in this one, it's going to go into our first catch statement, display catch 1 that corresponds with this. Then if we throw another error message inside this block, it's going to go into the corresponding catch statement, again inside of catch 2. Fantastic. And then same thing with this third one. It'll throw and it'll go into our catch statement and then continue running code. So again, the power of try catch is to be able to show more information and allow the system to continue running code both within the catch statement and onward if that's desired by the developer. So that's awesome, but there's one caveat with these nested try catch statements, and that is when you have TTS begin and commits. When you have a TTS begin and commit, the system won't go into the closest catch block. So you'll see when we throw an error message here, it will not go into this catch statement. It's going to go to the first catch statement that is outside of the TTS commit. And so this threw me off. I actually did not know this until very recently. I thought that try catch statements within X++ were unpredictable, that they didn't always work, but really the answer is they do work. It is just that TTS begin and commits are used a lot. And so if you're going to have a try catch statement, you need to make sure that you've got a catch that is outside your outermost TTS commit, and then you'll be able to catch that statement. So if I go in here, this nested try catch, come into this while select for fun, if I'm expecting this while select to loop and to actually catch and try the next invent table and keep going, that's not going to happen because I put this TTS begin and commit outside this loop. It's going to go to the first catch statement here and go into here. Notice it didn't go into this one, it went into this one. So this is the one that it's going into, the closest one after the outermost TTS commit. And then because we're not throwing another error message, it's not going to go into our outermost catch. If we did, it would. And then we get to the end of our job. Whew. So we ran through all the different examples of our try catch statement. Here's a couple examples where you can see in Microsoft code. This is in the DMF staging cleanup class. You can see they use a try catch statement. They've got a deadlock where they're retrying every single time. But then if they get an update conflict, they're actually doing a similar thing where they're looking at a retry count. And if the retry gets higher or equal to a certain number, then it's going to throw an exception again and in theory show that back to the user. Here's another one in dual write error logging. We've got a log error message with try, and we're doing a user connection, and then we've got a catch. And in this case, the catch actually doesn't do anything. It doesn't display any more information, but it does allow the system to continue going. And then it leads me to one final thing that's important to learn about try catch, which is this finally statement or finally keyword with a block. Finally's blocks will run regardless of whether you have the code go into a catch or not. So basically it's going to run all this code in the try, and then it's going to run the finally. Or if it ran some of the code in the try and then had an error message and jumped to this catch, it'll run the code in the catch, and then finally it will run the code in the finally. So the code always runs in the finally whether an error message happened or not. And you can see where it's useful. In this case, it's disabling or turning off connection. Typically within X++, this isn't needed as much because we don't have objects that we need to set back to null. You'll see this a little bit more commonly in other languages like C#, but as you can see, Microsoft still uses this within the X++ language. So this is one last thing to learn about try catches. So that was a lot to cover. Hopefully you learned something new about try catches. They're extremely useful. They aren't needed all the time. Very often you can have if statements that throw error messages, but try catches are really helpful when whatever process you're running might error in unpredictable ways and you want to be able to handle it and keep running code, or you want to be able to display more information back to the user so that they can understand what happened. So if you want to learn more about it, Microsoft has this page around X++ exception handling, and you can read more about different mechanisms for try catch as well. Okay, thank you so much for watching. Hopefully you learned something new today. I really appreciate you watching. If you liked the video, click the like button. I also invite you to push the subscribe button as well. If there's other topics you would like to see a video on, please post in the comments and I'll see what I can do. I hope you learned something new today. Thank you.